Hi students. The next one is carb element test or isocyanide test. Here this is an important test for primary amines identification. Or primary amines reacts with chloroform in the presence of alkali to form isocyanides. A very bad smelling or offensive odored isocyanates are formed. Here suppose I am taking a primary amine or NH2 reacting with CHCl3 plus a strong alkali is taken, that is 3NaOH, to give RNC. Here triple bond is present, one is a dative bond plus NaCl plus H2O is formed. This is a isocyanide test or carbylamine test. This isocyanide test or carbylamine test, it is giving a very bad smell, offensive odor. This is giving offensive, offensive odor. This offensive odor or very bad smelling isocyanide formation confirms the presence of primary amines. So whenever we are taking a primary amine, then it reacts with the chloroform, it gives isocyanates or chloroform conformation test also. Okay, suppose if you are taking the mechanism, it is a very simple mechanism or NH2. Here I am writing hydrogen, another hydrogen, and here there is a lone pair on the nitrogen atom, and this is CHCl3. So we will write a short form CHCl3 plus OH minus or NaOH if you are taking, then it forms carbon dichloride, that is a dichlorocarbene CCl2 plus H2O plus Cl minus is formed. This dichlorocarbene is the electrophile in this process, and here we are taking the dichlorocarbene Cl and Cl, and here there is a vacant orbital and there is a lone pair containing orbital on the carbon atom, and to this vacant orbital it donates the lone pair, and so it is forming a dative bond. So here this hydrogen and this chlorine atom, this hydrogen and this chlorine atom is removed, and then we are getting R N. Here already N and C, this is having two bonds because of these two, so we are getting two bonds, and the third bond is a dative bond. So this is a RNC formation minus a 2HCl formation occurs. Okay, this is isocyanide formation by the carbylamine test or isocyanide test. And in this process, the very important thing, the main important thing is primary amines only undergoes to this isocyanide test. So here primary amines only you must consider. Here primary amines means NH2 group containing an alkyl group and NH2 group containing. Means for example CH3 NH2 is a primary amine, or if you are taking CH3 CH2 NH2 containing, this is ethylamine, this is also a primary amine. Or if you are taking CH3 CH and CH3 and NH2, this is also a primary amine. This is NH2 group, that is important, NH2 group containing. It is bonded to secondary carbon, that is not a big issue. Here when it is NH2 group or not, that is a primary amine. And suppose if sometimes they may give CH3 C CH3 and CH3 and NH2, this is also a primary amine. So primary amines, either aliphatic or aromatic. Please remember, either aliphatic or aromatic primary amines will mainly undergoes to this reaction, and this is also called as a primary amine identification test. Primary amine identification test. Okay, so this is carbylamine test or primary amine test. Even if you take aryl amines also, PH NH2, aniline also gives. Secondary amines will not give this test. Please remember which compound will not give this test means secondary amines, tertiary amines will not give. Suppose if secondary amine is taken, secondary amine means NH or if we have or tertiary amine. Here tertiary amine means RN or R. These tertiary amines, secondary amines will not give this carbyl amine test or isocyanide test. Okay. The next one is Reimer Tiemann. Reimer Tiemann or Reimer Tiemann reaction or Reimer Tiemann reaction. Here this Reimer Tiemann reaction is also a very important reaction, and this Reimer Tiemann reaction means here phenol. The main reaction is phenol reacts with chloroform and alkali. Phenol reacts with chloroform and alkali to form salicylaldehyde. To form salicylaldehyde as main product. The salicylaldehyde is formed as a main product. Here we are taking the reaction. Suppose this is the phenol, benzene ring containing OH group. This is called as phenol. It is reacting with chloroform and base like sodium hydroxide. Alkali, strong base is taken, then it is forming orthohydroxybenzaldehyde, OHCHO. This is called as salicylaldehyde also, or it is also forming parahydroxybenzaldehyde. This is a parahydroxybenzaldehyde. This is called as orthohydroxybenzaldehyde, or it is also known as salicylaldehyde. Common name is salicylaldehyde or orthohydroxybenzaldehyde or 2-hydroxybenzene carbaldehyde, IUPAC name. Okay, this is the major product, and this is parahydroxybenzaldehyde, and this is the minor product. Why this is major means due to intramolecular hydrogen bonding. This hydrogen and this oxygen is having intramolecular hydrogen bonding. Because of intramolecular hydrogen bonding, it is a major. Okay, that is simply remember that. Okay, this is a phenol plus a chloroform and alkali gives salicylaldehyde. Okay, we need the mechanism for this reaction, that is important thing, and based on the mechanism they are asking questions also. We will see the mechanism now. Now see the mechanism of Reimer-Tiemann reaction, which is an important one. Here this is an important one. And in this mechanism, first we are taking CHCl3 chloroform, which reacts with sodium hydroxide strong base, and this is forming first CCl2 plus NaCl plus H2O. Dichlorocarbene, this is the electrophile. Please remember, in the reaction, the electrophile used is dichlorocarbene. So they are asking the question, what is the electrophile in Reimer-Tiemann reaction? That is dichlorocarbene. And in the next step, what happens means phenol we are taking. This is C6H5OH phenol. Phenol reacts with a base like OH minus, and this releases the proton. So we will get C6H5O minus. This is called as phenoxide. Phenoxide ion is formed plus H2O is formed. And phenoxide ion, now I am writing, this is the phenoxide ion. So here it is O minus and pi bond, pi bond, pi bond. And then this phenoxide ion is now undergoing to reaction with here this pair of electrons are shifting. I will write one more hydrogen separately. Okay, in the beginning, from the beginning, I will give the hydrogen, one hydrogen here separately. If this pair of electrons are shifting onto this, then this pair of electrons are shifting onto the adjacent carbon. So here we are having CCl2. This is called as a dichlorocarbene and this is the electrophile. Then these pi bond electrons are attacking on this dichlorocarbene. Already it has a lone pair, sir. Why it is getting attacked by another lone pair or pi bond electron? Even though it contains lone pair, it has 6 electron species. Electrophile means electron deficient species. So pi bond electron attack on this and then it is making a bond like this. Here C double bond is formed, oxygen is there, and here one more hydrogen already present, and a new bond is formed between CCl2. And so this pair of electrons are taken up by this, so it is already having a lone pair, so now it gets a negative charge. Okay, and we are having pi bond here, and already pi bond is present here. Now what happens means one hydrogen shift occurs. This hydrogen is shifting onto this carbon atom. By this hydrogen shift, this pair of electrons are shifting onto this and then this pair of electron shifts onto oxygen again. Okay, and here why this happens means it is actually aromatic. This is called as aromatic. Okay, aromatic are more stable and this is non-aromatic. Non-aromatic comparatively less stable. When this compared with this, the non-aromatic is less stable than aromatic, and this is also called as a rate determining step. Okay, rate determining step. And in the non-aromatic nature to aromatic nature, it will try to convert because it is unstable. So this is unstable. Immediately try to convert. Compared with this, it is unstable. Please remember, compared with this, it is unstable. So by immediate conversion, what is the product? Here you can check it. This is O minus, and now we are getting a new bond, that is a pi bond. A pi bond here, already pi bond present, pi bond is present here. This bond is shifted, so we have a new bond. This is a normal bond already present and CH bond is present, so you will get here CH and there is two chlorine atoms. So here it is one chlorine and this is second chlorine. Okay, that is the compound actually formed, and now this is reacting with OH minus. OH minus means, for example, two sodium hydroxide molecules are reacting, two chlorine atoms are replaced. So what is the product formed here is here it is phenoxide ion, here CH and pi bond, pi bond, pi bond. Now see, this is not aromatic but this is aromatic. So it is converting into a more stable ion. And here two chlorine atoms are replaced with the two OH groups. So two chlorine atoms are replaced here. I am not writing two chlorine atoms replacement, but two OH groups replaces two chlorine. But we know two OH groups present on same carbon is unstable. So you remove the H2O. You remove the H2O. By the removal of H2O, so minus H2O occur, then what is formed here? This is a O minus, pi bond, pi bond, pi bond, and now you have CH and one oxygen is only present, so it is CHO. And this phenoxide ion is present, it undergoes to protonation. Protonation, acidic hydrolysis or protonation occur, and finally it converts into phenol. So this is a OH and here it is CHO. This is the orthohydroxybenzoaldehyde or it is called as salicylaldehyde. It is called as a salicylaldehyde. So this is a final product and this is the mechanism for Reimer-Tiemann reaction. So please remember the intermediates formed also. Which of the following intermediate is possible? They are asking a question. Which of the following intermediate is not possible? They gave these two right up options. Please remember, if you have a double bond O, we are not having complete pi bonds in the benzene ring. If you have single bond O minus, we have a complete pi bonds in the benzene ring. You please check it. Basing on that, you can write the intermediate. Here O minus phenoxide it is phenoxide phenoxide. Finally, you will get phenol type. Okay, this is orthohydroxybenzoaldehyde or salicylaldehyde, and this is the main product or major product in Reimer-Tiemann reaction. Okay, so this is the mechanism for Reimer-Tiemann reaction. In this Reimer-Tiemann reaction, suppose phenol is given, we will get salicylaldehyde. Suppose if this is OH group and here we have a methyl group. This is called as paracrysol. Cresol means CH3 group and OH group containing benzene ring at para positions, then it is called as paracrysol. If it is at ortho position, orthocrysol. Okay, paracrysol is taken, and in this process, suppose if they are giving CHCl3 and NaOH or KOH, and sometimes they give temperature and followed by H plus. If this is the reaction condition given, it is again Reimer-Tiemann reaction only simply. But what is the final product? Here the major and final product is only ortho product is possible because already para position is blocked. So we are getting CHO and CH3. This is the only major product, and we are getting one main product. And the another important question they are asking basing on this OH, but here if they are giving CCl4, please remember, very important, sometimes they give CCl4 instead of CHCl3 chloroform. If they are giving CCl4 and NaOH, they gives same temperature, high temperature, and H plus followed they gives. When they are giving carbon tetrachloride, please remember, we will get salicylic acid, not salicylaldehyde. This is a COOH. This compound is called as salicylic acid, not salicylaldehyde. If it is a chloroform, we will get orthohydroxybenzoaldehyde or salicylaldehyde. If it is carbon tetrachloride, definitely we will get carboxylic acid. That is salicylic acid formation occurs. That is very important. Remember this. It is also asked previously. Okay. So this is about Reimer-Tiemann reaction. The next one, uses of polyhalogen compounds. In this first one is a CH2Cl2. This is called as methylene chloride or dichloromethane. This methylene chloride is mainly used as a solvent in metal cleaning and finishing. In the metal cleaning purpose and finishing of metals, we use as a solvent. And as a paint remover, to remove excess of paint, we use this methylene chloride. And as a propellant in aerosols, we prepare aerosols, and in that propellants we are using this CH2Cl2. What are the side effects of this methylene chloride? If it is in low concentration, then it causes impaired hearing and vision. We are getting a problem in hearing and vision. And if high concentration it is present, dizziness, nausea, tingling, and numbness in fingers and toes. Fingers and toes numbness is observed. Skin contact, if it is a directly contact with skin in high concentration, then burning sensation and redness of skin is observed. And eye contact, if directly methylene chloride is directly contacting the eye, it is in eye contact, then burning of cornea may occur, which leads to loss of vision. That is about methylene chloride. The next one, chloroform, which is used as a solvent for fats, alkalides, and iodine. And in the preparation of freon refrigerants like R22, we can use chloroform. And in olden days, actually, it is used as a local anesthetic, but because of its harmness, which is converting into phosgene, we are not using now. And main side effects, if it is more than 900 ppm in the atmospheric air, then it causes dizziness, fatigue, headache like. And in the high concentration in the body if present, it damages liver and kidneys. And next one is iodoform, CHI3, which is used as an antiseptic in previous or in olden days. And the antiseptic nature of this iodoform is due to free iodine, not because of iodoform. That is important thing. Please remember. Why it is the antiseptic means? Because of free iodine. Next, carbon tetrachloride. This carbon tetrachloride is used in the preparation of refrigerants, propellants like freons, and it is also called as a fire extinguisher under the name of pyrene. Commercially, it is sold as a CCl for used as a fire extinguisher. The next one is freons. Freons, we know chlorofluorocarbons. The important freon is freon 12, that is CCl2F2. They are extensively stable, non-toxic, non-corrosive, and easily liquefiable gases. And in beginning, means in the production of freons, in the beginning days of the freons industry, they found and they thought like they are boon to the industry. But later on, they felt, the scientists felt like it is cost to the environment because they are non-biodegradable. They are causing a lot of pollution. So now it is becoming a curse to the environment. They are trying to reduce the usage of freons. Mainly, they are best refrigerants. Okay, and in air conditioners and in fridge refrigerators, we use this freons. Next, DDT, dichloro diphenyl trichloro, dichloro diphenyl trichloroethane. This DDT is mainly found and it is effective against mosquitoes of malaria and that of lice which carry typhus. And how we can prepare DDT means chloral. This is called as chloral. This is a chloral, and this chloral reacts with chlorobenzene. This is called as chlorobenzene. Two molecules of chlorobenzene in the presence of concentrated sulfuric acid, and here O and here H and here H is removed. Minus H2O. Minus H2O. This is minus H2O. By minus H2O, finally, we are getting DDT, diphenyl trichloroethane. The IUPAC name, very rarely they ask, but better to know about the IUPAC name. That is 111 trichlorobis 22 4 chlorophenyl ethane. So this is 1, this is 2. So 111 trichloro bis 224 chlorophenyl ethane, that is IUPAC name of DDT. But in recent years, means after 1970, America, US banned this DDT usage, and so many countries also banned. But even some parts of the world, they are using this as for the treatment of insecticides, for removing or for reducing the insecticide effect.